Okay, gang, load up, there it is. So guys, quickly, I just want to run through the stuff that we got covered yesterday. We were talking about function notation, and we had really said the big idea yesterday was that we're seeing anything that looks like this form of f of x, we always said that was equal to really what variable? It's like a y value, okay? So the thing I think I said yesterday is, so ask yourself, do you have an input or do you have an output in terms of what we're talking about? Guys, this part right here, x, is like your input. It's saying you're going to input a value. The f implies that you're going to do something to that value. And then what you get out is like the y value or your output from yesterday. Okay? So these were our central questions and our goals yesterday. Just a quick recall on this. Guys, in example 1, it said to evaluate f of x equal to x minus 7 when x is 4 and when x is negative 4. I'll just review the x is 4 part. When I give you an x value of 4, am I giving you the input or are you giving the output? If I say, hey, in this function, x is equal to 4, are you given the input or are you given the output? You're given the input. So essentially what you're asked to do is to determine what is f of 4 equal to. They're saying, hey, I want you to input 4 into the function 2x minus 7. So this would be 2 times, replace the x with a 4, minus 7. And I think we got 1 for that yesterday. Is that correct, guys? I think we did, didn't we? All right, so then this implies that f of 4 is equal to 1. And then I think we talked graphically, and we'll look at some more examples like this here in a second. But graphically, we said, hey, this is just like the point when you input 4 and get out 1. This is like plotting the point 4, comma 1. All right, so that was a quick crash course there. We've got through example 2, and I said if there's anything I want to make sure that you're completely aware of and totally understand, it was example 2 yesterday. Talked about this idea that we're going to start measuring the temperature at what time, guys? What was our reference time? 10 o'clock. And we said explain the practical meaning of everything here as it relates to the temperature outside after 10 a.m. So what did we say yesterday in our notes about f of 0? If f of t represents the temperature outside t hours after 10 a.m., what was f of 0 again yesterday? What did that mean? It's the temperature at 10 a.m. because the 0 implies 0 hours has elapsed since 10 o'clock. So this implies that this is the temperature at 10 a.m. Okay, very good. Good. Part B. What did we say about part B? We had f of 3 was equal to something this time then. The 3 was an input, the n was an output. What did the 3 do for us? What time did that move us to yesterday? What time did the 3 move us to yesterday? 1 p.m. So what did we say on this one, Nolan? Temp at, I say 1 p.m. because that's 3 hours after the initial time, so the temp at 1 p.m. is, in our case, n degrees Fahrenheit. Great. So I think first page, we were pretty good on that yesterday. How do you guys feel about that? Great. Just like Tigger. There. Great. Oh, Rod, isn't his name? Oh, what's his name? Tony. What did I say, Tigger? Tigger's a bouncy one. He likes the boat. All right, so I'm off. All right, forgive me. My Disney isn't completely correct. I know my math. I just don't know my Disney stuff and my cereals. You guys were quick to pounce there. I get it. All right. Excellent. What do we say about the last one then? F of 1 greater than f of 8. What did f of 1 represent? Temp at 11, 1 hour after 10, right? Warmer or colder? It says greater than here. Warmer or colder? Is warmer. Then the temp at, what was the second temp? 8 hours past 10. What would 8 represent? What time?
6 p.m.
6 p.m. 8 hours after 10 would be 6 p.m. Very good. All right. So I think we were pretty good there. We got through example 3, didn't we? Did we get through example 3? Okay. I just want to make sure we clarify how 3 and 1 differ. We'll look at these on your own quick again. And we'll get you through the last couple of examples, and I'll give you some time to get some things done today. Solving for the independent variable. So guys, again, if you can kind of think of the left side out here as, well, whatever value is over here is like the output. And what's going in for x is considered your input right here. Okay, as it says, for g of x equal to the following function, 2/3 x minus 5. It says find the value of x if all of g of x is -7 this time. Okay? So that -7 up there, am I plugging -7 in for x, or is -7 your output this time? What's it say is equal to -7, guys? Does it say x is equal to -7 being the input, or does it say g of x or my output is -7? Which one is this? Is the input -7 or output -7? The output is. So the -7, is that going to go in for the x, or is that going to go on the left side of the equation when I substitute? It's going to go in for the output value of or of g of x here. So what we wrote yesterday was -7 equals 2/3 x minus 5. And again, what are we trying to solve for this time, guys? What's it say to try and find or solve for? X. So if it says find x or solve for x, don't you have to have an x in here somewhere to solve for? That's kind of a dead giveaway in terms of where to put it, isn't it? So when we solved this yesterday, we added 5 to both sides. We had -2 on the left equals 2/3 x. Remind me again how I got rid of that fractional coefficient. Multiply both sides by 3/2. Cancel, cancel. What did we end up with a solution yesterday? What kind of 3, kiddo? If I went 3 times -2 here, that would be -6. -6 divided by 2 would be, again, Emily? -3. Perfect. Okay. Sonia, on your own, did we get through that yesterday?
Yeah.
All right. How about a volunteer to explain to me what to do here for this first one then? Do I have the input or do I have the output? Volunteer to help me with this one. How do I solve for f of x equal to the function 3x plus 6? What's it mean to find f of -2? Is this part in parentheses an input or an output? It's an input, so I have to plug it in for x. So we're going to say f of -2 right here equals 3 times -2 plus 6. I think we got 0 out of that, didn't we? Okay, so we have a 0 when we get this. So f of -2 was 0, right? So this one right here, you knew the input. You knew the input. Now the second one differs a bit. Instead of knowing the input, what do we know this time? What do you know in that second example? Input or output? You know the output. It says solve for what? X. So we have to leave the x alone. So we're going to replace all of this g of x on the left with what value? 12. So we'll say here, hey, we know the output this time. We knew the output before we started this. We knew the output. We're going to say 12 equals 2x minus 8. Again, if I'm solving for x or looking to find out what value that is, don't you have to have an x in there to solve for? Well, yeah, you do. And if you don't, something's wrong, right? What's the first step in solving this now? Don't all speak at once.
You have to add 8 to each side.
Add 8 to each side, in which case you have 20 equals 2x, and finally divide by 2 gets us again how much?
10.
10 was the input. Okay. So I think we were up to that point yesterday, right? So quick crash course of what we did yesterday. I know I went quickly through it, but I think we had a pretty good hold on what we were doing yesterday. All right, so here's the good part about this, guys. Graphing function notation. I love this problem right here. I'm gonna start by doing this. Anytime you have to graph something here, again, we've talked about, do you know the inputs or do you know the outputs for all this stuff? Okay. Anytime they ask you to graph something, hear me on this. You're gonna end up setting up an XY table, basically. Over here, I'm gonna put X, but instead of putting Y, I'm gonna put in what? F of X. FX. That's a TV channel, isn't it? Yeah. Got some good shows on there usually, don't they? They do. Especially around July 4th, Independence Day. That's a given. With all the aliens. Aliens exist, trust me. Oh yeah. I don't know about zombies so much, but I'm convinced that the aliens built the pyramids. I really am. We did. And I'm telling you what, I will never believe that human beings built them with all the mathematical background that's behind them. I believe that aliens built them. They could not have been that sophisticated back at that time. There's no way. No way. We should watch that in Mrs. Wilson. Have you ever seen the belief that aliens built the Great Pyramids? That's pretty darn interesting, and it'll make you think.
He said that though, Will.
What's that?
You said that last year that you'll
Someday it might happen. I thought the one day where the power outage happened here at school, that quick little blurb, remember that morning? I thought the apocalypse was starting there. Okay. Yeah. No, I do. I'm fascinated by some of the things that astronomers talk about in terms of different galaxies and different stars and different worlds, and now that scientists believe now that they have evidence that there's another Earth in a different galaxy with people on it. So I don't know. It's interesting to me. Guys, every time we do a graph, this is what I want you to do. Make this a constant every time. I want your inputs to be what 3 values every single time. Use 0, 1, and 2. And I choose 0, 1, and 2 because mentally, aren't those numbers pretty easy to work with? All right, 0, 1, 2, pretty easy to work with. So basically, I'm saying, hey, if they ever say, I want you to graph stuff, this is what I want you to do. Input 0, 1, and 2 to try and form a graph here. Okay, so guys, as my input would be 0 into the function f of x, 3 minus x right here. If I input 0 up here, what would the output be? 3. 3 minus 0 would be 3. All right. How about if I input 1? What's that get you? 2. So that must write that as a 2. And then what if I input the 2? What do you get out? 1. All right. So we have to graph that. So I'm going to zoom up a bit on this. Guys, basically what we've done for ourselves is create an XY table, in which case you know the input and the output. So the first point I'm really looking to graph right here would be the point 0, comma what? 3. How do I get to 0, comma 3?
You
Start at 0.
Go up 3.
Go up 3, and there's that point right there. Okay. Next point you're plotting would be 1, comma 2. So write 1, up 2. And then finally write 2 and up 1. And it looks like to me the type of graph that's being formed here is some kind of a, whoops. Some kind of a line right here. So we'll do this quickly. If you have some kind of a straight edge, you might just want to draw a center. I'll do the best I can to draw a straight line. Pretty good. I'll fix it. I can fix it. Ma'am. So guys, keep in mind again, I've formed a graph right here. Now I only gave you 3 different points. I think the thing that's kind of unique about this graph is the following. If I would pick a point over here and say this, actually I'm going to add to my table a little bit. I'm going to change colors here. If I did this to my table, I'm going to put a line down here and put a couple other values in here. Without even having to put stuff into the function right here, let's just suppose I knew that my input was maybe, I don't know, 4. If If my input was 4 right here, over 4, how far down would you be on that graph? I need to fix this just a tad bit more. If my input was 4, or the x value was 4, what would the output be? What value would that match on the y-axis? -1, wouldn't it? Okay. So here's a question for you, based on this graph. Here's a question for you. I'm telling you that my output is 7. The output in that graph is 7. Output is 7. I want to know what's the input. Now, the output is 7, so what is my input? It's an output of an x value or a y value. It's a y value. So I said the y value is 7. So go all the way up to 7. There it is, right here. What input value does that match down here? -4. Okay. So if the output value is 7, what's the input? -4 based on that graph. Okay. So the other thing, stand after you've got a few points in here, and this is graph, how you can determine input and output values then from your graph. Are you okay with that? All right. Good. All right. Next page here quickly. Last page. Okay. You'll see some problems that look a little bit like this here. Functions are really good for making comparisons to tables or graphs, and they start using things a little interchangeably here. And a real life example right here, this is what we're looking at doing. It says the function c of x equals 25x plus 50 represents the labor cost in dollars for certified remodeling to build a deck where x is the number of what? Hours. Okay, so they're going to take some time and build a deck. That'll be just the labor cost, not the material, but just the labor. So certified remodeling over here is defined as, I'm going to write this down here. I'm going to put a CR up here. Whoops. I'm going to put a CR up here, which stands for certified remodeling. Their labor costs are denoted by the function that they give you. C of x equal to 25x plus, where is it, 50. Okay. It goes on to say right here, the table that I have right here shows the sample labor cost from its main competitor, Master Remodeling. So I'm going to put MR up here, Master Remodeling. It says the deck is estimated to take how long to build? It'll take us 8 hours to build this thing. Which company would you hire? Now guys, if we're all thinking the same thing and we want to keep labor costs down, we would probably hire this company that's going to be the most expensive or the cheapest. Hopefully with the assumption that they're going to both do quality work, right? Okay? Sometimes you get what you pay for, all right? Well, the cheaper cost would be the better one to go route with here, but do I know what 8 hours would cost from Master Rebuilding based on a table they provide? Does it list it for us, or do we have to find it? We have to find it. Is there enough information in the table, or is there enough of a pattern, I should say, in the table to identify how much you would pay for 8 hours? Okay, I see a lot of people shaking their head yes. Jacob, you say yes here? Well, how are you going to find 8 hours worth of cost from Master Rebuilding? So for every 2 hour increase, this increases by 30, is that right? So another $30 jump rate here. Another $30 jump for another 2 hour jump right here. How much is that cost going to be again? $220. So the cost for 8 hours of labor for Master Rebuilding would be $220. I'm just going to jot that down up here. Okay? Now, certified remodeling does not give you a table. They actually say, hey, we compute our cost on a function C of x equals 25x plus 50, where x is your number of hours. So again, how many hours are they going to perform the task? 8 hours. So that 8 hours is like an input into our function. And if I input 8 hours into the function, that'll tell us what a labor cost is. So what we're really looking for over here, kind of divide this up, What we're really looking for over here is C of 8. I want to know what C of 8 is. What's the cost of 8 hours of labor? Well, input 8 into the function. 25 times 8. Anybody know 25 times 8? 200. Plus how much more? Plus 50 according to the function. So 8 hours of labor for certified remodeling will be $250. So based on the labor cost by table or by function, which of these two companies do you probably want to choose? And why? I'm going with Mastery Building because they can do the same job for less. Okay, so choose Master Rebuilding. Because it is what? Okay, very good. Because it's cheaper for 8 hours of labor. It's cheaper for 8 hours of labor. Okay. Guys, what questions have you got over this? Okay, I'm going to go ahead and stop this.